Hello and welcome to Pixel Driven, a YouTube channel all about learning Unreal Engine, specifically for automotive rendering. I'll be presenting these videos from the perspective of someone coming from a production background in Maya, and make an effort to draw parallels between the two programs. Part 3 of this series is going to be about materials in Unreal Engine. We'll do a deep dive into how materials work in Unreal, how they differ from Maya and Maya plugin materials. We'll create a look dev level, and then we'll create several different material types that are useful for automotive rendering. So we're going to start off with essentially explaining what a material is, right? So a material in Unreal Engine or any 3D application is just a description of the surface of an object, right? What is that surface made of? Is it plastic? Is it metal? Is it glass? Is it smooth? Is it rough? All of these kind of attributes of a material, we need to tell Unreal Engine what those are. And we do that by designing a material in the engine. So one of the biggest differences between other programs and a game engine when you're thinking about materials is that in a game engine, they don't really do anything out of the box. The defaults that are there are extremely simple. So let's jump over into Maya and kind of see what the flip side of that is. So I've got the Hypershade open here, and we'll take a look at an Arnold standard surface shader. This is an unchanged Arnold standard surface shader, and we can start rendering this in the viewport. I've got a simple HDR in here just so that I can see something. And so we see that the default Arnold standard surface is just kind of like a bright gray semi-gloss surface here. If you look at the attributes of that shader, it's got tons and tons of attributes in here to help describe what the surface of this material is, right? So we can change the color of it. We can change the roughness of it if it's very glossy or very rough. We can make this metallic. So if we turn metallic up and the color up, we've essentially got chrome at that point. And so we can pretty easily change all these attributes to make tons and tons of different types of surfaces just out of the box with a standard material. In Unreal Engine, it works a little bit differently. And you have to keep in mind that Unreal Engine is a game engine, first and foremost here. It wasn't until the last few years here where they really started to embrace features that are more useful to something like product visualization or car rendering, right? So game engines, what's the most important thing for a game engine? It's optimization, right? Games are built for very specific target hardware, whether that's an Xbox or a PlayStation or a Nintendo. You only have a finite amount of GPU memory. You've got a finite amount of processing power, RAM, all of these things. And when you're creating games for these platforms, you have to fit your entire game onto that piece of hardware's capabilities, right? So game engines are built very, very Spartan, right? Out of the box, they don't do a whole lot. You have to tell it to do things on purpose because the baseline, when you're creating assets in a game engine, it needs to be as optimized as possible. So if you had a material in Unreal Engine that did all of these things, that's going to be a very, very expensive shader if you're worried about rendering in real time, right? If you're trying to render 60 frames per second, you have all of these features programmed into your material. It's just going to be a very, very heavy material. Like an Arnold standard surface can be just about anything. And the same goes for a V-Ray material or a Redshift material. All of these renders, they kind of work in the same way where they've got all of these attributes pre-built into it. And so if you think of an Unreal material, none of these things really are there by default. It has inputs for all of these things, but they aren't typically really going to be used just out of the gate. So you need to program in the ability to plug in a texture. You need to program in the ability for it to be transparent. And so we'll learn how to do all of this stuff here in Unreal in the next few parts of this video. So we're going to hop over into Unreal. And I've got a new project that is continuing to build off of the last two videos here. So we'll get this open and we'll talk about a few things here about materials. So you can see we're in our same main level that we had last time. All of our assets are still there. I'm going to go ahead and clear out some of this stuff. So we'll remove those toruses. Our cube can stay there. This can stay our main level, that's fine. And one of the first things that we want to do is talk a little bit about the material systems in Unreal, because there are more than one material system here. So Unreal by default is going to have the standard Unreal material system activated, right? And in very recent versions of the engine, Unreal has been developing a complete overhaul to the material system. It's called Substrate. And we're actually going to be using Substrate for this course because it gives us a lot of new features for materials that are specifically really great for automotive rendering. Just a little bit of history on materials in Unreal. It used to really struggle with a few different material effects, particularly transparency, right? You know, it being a video game, it just, you look at most video games, even if it's an incredibly beautiful video game with amazing graphics, the one thing that you're going to be lacking in almost every one of those examples is really high quality looking glass, pretty much anywhere, right? So Substrate is a new material system in Unreal that gives us much higher quality effects like glass, being able to layer materials, being able to have something that is both metallic and non-metallic in the same material, being controlled by masks and things like that. So there's really huge benefits that we get from going to Substrate. So to enable it, we're going to go up to Edit Project Settings, and we're just going to search for Substrate. Right, so we've got here under Engine Rendering Substrate, Substrate Materials, Experimental, so in parentheses here. So this is just to tell you that it is not complete, right? Substrate is not at a version 1.0 state yet. It's still in experimental phase. And you'll see this as you learn more about Unreal Engine. Unreal features tend to go through different product cycles, right? So I'm going to open up a new page here, and we're going to search for the Unreal roadmap. So Unreal has a public roadmap, and you can see all of the major features that have been released, you know, in the different versions of the engine. So right now, Unreal Engine 5.4 is the latest one. These are the features that were launched with that version. If you go to the forward-looking section here, you can see what's coming in future versions of Unreal. Right? So one of those things here is Substrate beta status. So new features in Unreal, they go through development cycle that goes from experimental to beta to production, right? So right now Substrate is in experimental. It's probably got a lot of bugs in there if you get into really specific scenarios. But when we get to beta status here, it'll mean most of those bugs have been resolved. There's only a few left. And then when it hits production phase, it basically means it's safe to use to build video games with, essentially. That's really the main thing that they're basing that off of, is it's safe to build and ship video games. So for us, doing automotive rendering, I'm okay with there being a couple of little quirks in it. You know, there's some things that are not quite complete, some things that could be little drawbacks, but I've found that it works for 99% of the materials that I need to make for an automotive project, right? So you'll need to turn this checkbox on, and as well as the second one here. And turning those on, you'll get a little message that says Unreal needs to restart. You'll click the restart button, and you'll see Unreal shut down. Your splash screen will come up, and it'll recompile all of your shaders again, because this is a whole new material framework that it has to compile the shaders with. It needs to go through all of that again. So I'm not going to make you watch that in this video. I've already set that up here. Substrate is active in the project. And so we can go ahead and start building a material look dev level, right? So it's a good idea a lot of times when you're working in Unreal to have just kind of an area in your project where you can develop the look of assets that you know that is, you know, if you go into this much detail, but you can have it be calibrated to a certain lighting environment, you know, that all the materials that you're creating are going to look good in the rest of your project. typically what can happen is if you are designing materials in one setting that's maybe very bright, or the lighting is fluorescent or something like that, you'll be tweaking all these materials based on that lighting, and you put those materials into a different environment, they might just look totally off. So it's best to design materials in something that's pretty, neutral and natural. And there's a couple of tools in here that we can use to help do that. So we can go ahead and go make that look dev level. So I'll go to my content browser here, and I'm going to make a new folder for materials. And inside here, I'm going to create a new level, and we'll call this material look dev. Save that. So we'll open that level. Should be an empty level. And we need to start basically creating a little stage for ourselves to be working on to view our materials. And so there's some great assets that are built into the engine to help us do this. And if you remember our filters here. So what I would say is to go to the engine folder and then click on the static mesh filter to see what static meshes are available in the engine here. And there's a bunch of different shapes in here that we can use. We can borrow from the engine to use as something to look at for our materials. And there's a great one in here, SM Matte Preview Mesh 01. I'm going to take this and drag it into this level. I'm going to zero this out. Okay, so we've got an object to apply materials to. We can see right now it's a static mesh. It's got 3 material elements on it. So remember when we talked about face assignments in materials in static meshes, if we open up this object, we can kind of see what this is, right? So it's a shader ball, essentially. So we've seen these all over the place in the past when we're looking at materials in different programs. It's kind of like Unreal Engine's version of that, right? So it's got 3 elements here. And this is a great time just to talk about a little bit more about how these elements work. So you can see under the materials slot section here, there's element 0, 1, and 2. And these all have, the opportunity to drop different materials on. So there's a couple of checkboxes here that are really useful for finding those areas on your object. So like what part of this object is element 0. So you can highlight, and you might notice like this is not really all that useful. It just kind of looks like it selected the whole thing. You can see little faint lines in between here, but the more useful one here is going to be isolate. So we can really see, what area of this object is element 0. So we can do the same for element 1. It's kind of those little pieces. And then element 2, it's going to be just the logo here. Okay, so this is how material slots and elements work on an object in Unreal. We can assign different materials to these slots to really customize this object. And this is what you would do if you had a pretty complex object that you didn't want to bring into Unreal as 1,000 pieces. You could combine all those things down after you've got material assignments done in Maya, and it'll essentially be one object with multiple face assignments at that point. So you could bring in an object that has 100 different material slots on it, and that's totally fine. Unreal can absolutely handle that. Okay. So we've got an object, but we can't see it. There's no light in the scene. And one thing I would recommend using for doing material development here is going to be just using an HDR. So under Edit Plugins, we have to enable the HDR plugin. It's not enabled by default. So if you search for HDRI, you can see there's a plugin here called HDRI Backdrop. And I've got it turned on already, but it'll be turned off for you by default. So we'll turn this on, restart the engine. That should just take a moment. It shouldn't need to compile too much when you do it this time. And you'll be able to create HDRI backdrops in your scene. So you can find those under the Place Actors panel, Lights, HDRI Backdrop. So that'll create an HDR in your scene. So there's a few attributes on an HDRI backdrop that I like to change pretty much every time when I use them. So first of all, I'm going to stick it to the origin here. And you'll see that there's a few different settings here. One is what map is going to be assigned to this. It comes in with this by default. And if you remember, you can double click assets to see what they look like. So it's like a farmland HDR here with a bright sky. There's the intensity of the HDR, which If we set this down to like 0.5, you'll see it get darker. And I don't know how well you can see it through the recording, but my screen very slowly brightened up a little bit there. Kind of came back to that same level that we saw before we adjusted that. And it's like, why is that? So maybe we'll drop it down to 0.1. We'll see it get darker, and it slowly brightens back up, right? So this is a feature in Unreal called eye adaptation, which is on by default. It's kind of simulating how our eyes will adapt to different levels of light in nature, right? So you'll notice this really pretty dramatically if you're in a dark room, you're working at a VFX studio, there's no windows, everything's dark so everyone can see their monitors really clearly. And then you open the door, you walk outside, and it's like your eyes are burning all of a sudden. It takes a minute for your eyes to adjust to that sunlight. That's eye adaptation. That's what Unreal is trying to simulate here. For us, when we're rendering still images and videos, that is really not great. I typically will turn that off 100% of the time. I like to design lighting that is consistent, and I know what to expect from it. If I turn my camera towards a light and it's brighter all of a sudden, I don't want the exposure of my scene to change, right? So this is where post-process volumes come into play. So under the Place Actors panel, there's Visual Effects, Post-Process Volume. So it's going to drop this kind of a wireframe square into our scene. I will pull this over a bit here just so we can see it. It creates this wireframe square, and it doesn't really seem like it's doing anything by default, because by default it's almost like there isn't one in the scene. It's not really doing anything. It's not overriding any of the render settings yet. So with this selected, and you look at its details panel here, you'll see tons of attributes that kind of all relate to rendering. So I'm going to collapse all of these so we can get a look at everything. So we've got transform attributes, which really don't matter for this in the way that we're using them. We'll see why in just a minute here. You've got the lens settings. So the lens of whatever camera you're looking through, this is going to globally override those settings. And one of those things is exposure. And this is really going to be pretty much the only thing that we look at in this video as far as post-process volumes are concerned. We're going to do a much deeper dive into this in the lighting video and see everything that we can do with this asset. So under exposure, there's going to be metering mode. So right now, by default, it's set to auto exposure histogram. And that's why we're getting this eye adaptation effect. So like if I crank the intensity of this to 10, it's going to expose down my camera until it looks normal again. If I set it to 0.1, it's going to go really dark for a minute, and it's going to slowly adapt back up to that flat line. Right, so with our post-process volume, we can set metering mode to manual, but nothing changed, right? So it kind of seems like nothing happened. That's because post-process volumes by default, they work by essentially a camera needs to be inside that volume and looking out from it for it to have any effect, right? So this affects cameras. So if we move our camera over into it, our screen goes black. That's because our exposure compensation is currently set to 1. So if I start stopping this up, 3, 4, 5, 10, now we can see our scene, clearly it's exposed properly, right? But you may not want to have your camera stuck inside that volume at all times. And so there's an attribute on this post-process volume called infinite extent. So if you search for infinite, you'll see infinite extent unbound. So if you turn this on, it doesn't matter where you are in your level, this is now going to override the entire level. So your camera doesn't need to be inside of it. You can take the post-process volume and just stick it anywhere. I usually just kind of leave it off to the side, and I'll select it from my outliner here. So that is a post-process volume. We're going to go into a lot more detail on this later, but this is one of the first things that I usually change every time I'm in a new lighting level, right? And I want to control the rendering features of that scene. So we'll go back to the HDRI backdrop here, and we're going to change a couple of more attributes about this. So right now you can see our intensity is at 1, that's fine. The size here is going to change how big the dome is on this asset. So this controls the size of the dome on this HDR. So if I move my camera back, like way back, and remember to speed up your camera to do this, you can see the actual dome itself here. So if we change this size to 100, it's going to shrink the dome 50. I usually will set this is kind of an arbitrary value, but I'll set it at 1500. So it's pretty large. And you'll see that HDR stretching to meet the corners of that dome because it is, kind of a half dome shape. It's not a full sphere, right? And if you actually look at the wireframe here, you'll see the geometry that is associated with that asset here. So I went into wireframe here, and this is kind of a nice little point to where we can talk about view modes in Unreal. So I'm currently in the wireframe view mode now, and that is this menu right here. So by default, we're in the lit view mode. We can go to unlit, which shows the objects with no lighting information. We can go to wireframe, which we just saw. We can go to detail lighting. We can go to lighting only. We can see reflections. And this is one thing that kind of tripped me up when I started learning Unreal. This reflection view, this is not like looking at a reflection AOV in a Maya render. This is actually just simulating what your objects look like if everything in your scene has chrome on it. So it's not a reflection pass. It's just, this is showing us generic reflections of everything in the scene being chrome. So don't let that mislead you like it did me. And there's a bunch of other stuff in here that a lot of the stuff we typically won't use, but these first several here, lit, unlit, wireframe, I'll switch between these really often. And you can see that these have keyboard shortcuts. So going to lit mode is Alt 4, wireframe is Alt 2, unlit is Alt 3, and so on here. So those are the view modes in the viewport here. So we've got our HDRI. We set the size of this to 1500. And if we move, we come to the center of it, it starts to look normal. The farther away from that center, the more stretched everything gets. And so this can be a little bit annoying to work with within render scenes like this. So there's a way to override the behavior of this, and that is under the advanced menu here. So under advanced, there's going to be use camera projection. So if we turn this on, now it doesn't matter where we are, relative to our subject. The HDR is kind of always going to look the same. And it's not going to warp, it's not going to stretch. The disadvantage of this is that you kind of don't get the ground plane effect anymore when you do this, or if it is casting a shadow, it's not going to actually look like it's stuck to the ground. So in my experience, this is one of the bigger limitations to using HDRs in Unreal. Typically, you'll need to build out a 3D foreground for the best results. And that's what I've done in production for a lot of projects. We'll build out a completely 3D foreground that the HDR just kind of surrounds and acts as the far away features, the sky, the sun, that kind of stuff. And then one last attribute that I like to change on this is lighting distance factor. So it says specify the ground area that will be affected by lighting and shadows. I usually will take this and set it to 0, and you'll see that ground kind of lit up a little bit. So we set it to 0.5, the default kind of darkens down a little, but I'll set it to 0 because this is like essentially how an HDR would work in Maya if you had a full spherical HDR light in your scene. All right, so I'm typically looking for more of a one-to-one between Maya and Unreal when I'm lighting product shots and lighting cars. This is how you would do that, or this is how I would do that. So that's our HDRI setup. One last thing that I want to do before we move on is our material sphere here. Remember how we looked through our orthographic views in the last video? If I go to the front view on this, I can actually see that this asset is pointing forward Y on here. So I'll take my rotate Z value here and I'll set that to 90, just so it's pointing towards the front view in Unreal. Just trying to keep things consistent. You know, we can go back to our perspective view. And actually you can see I got that backwards. So I'm going to set this to -90. It can be a little bit deceiving when looking at the wireframe sometimes. All right, so our HDR is set up, our subject is set up. There's a couple of other assets that we can add in here that help in calibration. So the same folder that we found this material sphere, you can see this SM color calibrator. You can pull one of these in and reset this to the origin and just pull this off to the side and pull it up a little bit. A lot of times I'll just make this a little bit bigger. And so we can see, you know, kind of like a Macbeth chart here. We've got all of our standard values. You've got a medium gray, you've got glossy, you've got a chrome ball, and you've got a black glossy surface here. So a lot of nice things to see just to calibrate your renders. If you're going to take this as far as doing renderings to really calibrate your materials based on like a color controlled environment, you know, this is helpful for that. But we can control things a little bit more by eye here, and I think right now this is great for that. It gives us a good baseline. At least we can tell that we're not super far off at this point, right? So now we can start talking about how materials in Unreal Engine really work, right? So we briefly mentioned, you know, Substrate, the new material system. We took a look at some materials in Maya and how those are pre-programmed. Let's actually make a very basic material and kind of talk about some concepts around that, right? So we're in our materials folder. I'm going to right click in here and say create a basic asset material. And we're going to call this m_basic. So the m_ is kind of a naming convention in Unreal that stands for master. So there's a concept in Unreal of a master material and a material instance. And we'll see why that's really important and how powerful that is as we talk through this. But essentially, master materials are where you are programming those features that we see pre-programmed into like an Arnold material. We're going to program those features ourselves in a master material. So we're going to open up this master material and we'll see the material graph here. So it's got two nodes here by default. You've got the material output node here. So this one that's topped in brown up at the top here. If you hover over that, it'll say result node of the material. So this is the final result. And then right now we've got a default node plugged into this that says Substrate UE4 default shading. And this is basically Unreal's new way of saying this is a default material in here. This has its own inputs. There's nothing plugged into them, but they do have default values, right? So if you hover over these, you can see base color is 0.18 for RGB, metallic is 0, specular is 0.5, roughness is 0.5. There's no normal input, there's no emissive color input, and there's no opacity input. So what we're going to do is just delete this because we want to build the material from scratch here. And you can see from our mbasic output node here, it's got this purple input for front material. So this is a new concept in Unreal for the Substrate material system. This is going to be the result of the material graph that we build. So what we need to start building that material graph is called a substrate slab, right? So we're going to open up the tools menu here. You can either right click or hit tab and you can search for slab, right? So we'll see substrate slab. So this is, you know, one of the main building blocks of a substrate material in Unreal Engine, right? So we'll take this output node on the substrate slab and we'll plug that in with left click to the front material. So we'll see right away we get a result here. So this has its own default values. So it also defaults the diffuse color to 0.18. We've got F0, which is the facing specularity. So right in the center of this, looking right at the camera, that's the F0. F90 is going to be the glancing angle, what the color of that would be. So it kind of has the ability to do Fresnel functions built right into the material here. And this is a new thing in Unreal. This is a really powerful concept for customizing the specular look of a material, right? So if you think about things like Carpaint, where there are different facing colors and flop colors on a Carpaint, we're able to program those things separately from each other and have them be different values. It's really powerful. We've got roughness, which defaults to 0.5. Anisotropy here, it defaults to nothing typically, so there's no anisotropy active. It's got a normal input, tangent, and a whole lot of other things that we'll take a look at as we start building materials. But since we want to build a very basic material as our first material in Unreal, we're going to just create a diffuse albedo input here. So within our nodes, there's tons of nodes in the material editor here that we can use to start programming material graphs, right? So I need an RGB input for the diffuse albedo. I want to be able to make it, any color on a color wheel. And the way that we do that in Unreal is a constant node. So if you're familiar with Nuke, for example, you've got a constant node in Nuke as well, and that's used to make, solid colors. So we've got a constant 2 vector, 3, 4, there's a few different ones in here. So a constant is going to be just a single float value, right? So this is used for making one channel of a color or one grayscale value. So you can plug this in. It's 0 by default here. You'll see the material here turn black. If we make this 0.5, it'll be a medium gray. If we set it to 1, it'll be white. So if we set this to a constant 3 vector, you'll start seeing something looking pretty familiar here. So we've got an overall output. So this is the combined RGB output here, this white output node or output pin. And you've got individual pins for the red channel, the green channel, and the blue channel. So we can take this combined output here and plug that into diffuse albedo. And then you can double click this swatch to bring up a color wheel. Or you can change it here on the material expression constant here in the details panel. You can open this and adjust values here as well. You can also open up that swatch right from this little swatch here. So we can change this value to some other color. Hit OK. That'll update what color was in there, and we'll see our swatch update. So we'll hit save on this. It's going to apply the changes to this material, which is the same as hitting this button. If you save, it does this for you. And then we can close this. So we've got our first basic material. And we can assign this in the viewport here by just dragging and dropping it onto an object. But if you remember, this object here has multiple material slots, right? So if you want to be sure you get it on a specific material slot, you can select that object and then drag and drop your material to that slot. So I'm going to go put this on element 0, and we'll see that turn this kind of seafoam green color. So there's our first material in Unreal Engine. Super, super basic, doesn't really do much of anything except dictate that it's a very specific color, right? So what if you want to be able to customize this and be able to change the color on this without having to go into your master material every time? So Unreal has this concept of master materials and instance materials. And master materials, like we said, this is where we're programming the ability to make these things. And the way we do that is by turning these inputs into a thing called parameters. So most of the nodes that you create when you're building a material graph like this, you can right click it and say convert to parameter. So now you can see this changed the type of the node that was there. It swapped it out for a parameter constant 3 node. And it wants us to give it a name. All right, so we're going to call this diffuse albedo. So now we have a parameter version of our constant 3 called diffuse albedo. We'll save this. And now we can create a material instance of this master material. And you do that by right-clicking and say create material instance. So now we have a material instance asset here compared to the material asset. And we're going to call this mi underscore basic. So m underscore basic for master basic, mi underscore basic for material instance basic, right? So we'll open up this instance material. You can see our interface is totally different for this. So you can see here under parameter groups, we've got global vector parameter groups. And the reason that parameter that we created is under a section with this really weird name is that that parameter that we created was a vector parameter, right? It was a node that has multiple channels in it, or a vector, right? So the way parameters work in a material instance is that they need to be enabled here with this checkbox. And now we can change this value. So we can open up this swatch and make it blue, for example. So we'll save this material instance and close it. So now we can take this material and assign it to our element 0 on this object. So we've got a blue material now. So the cool thing about material instances is that you can change these things on the fly without recompiling that master material. So if I want to, I can come in and in real time change the color of this object now. So we can make it red. And we can save that. Now we have a red object in here. So let's add a couple of features to our basic material here. Let's add the ability to change how rough it is. So maybe we want to make this look more like a shiny plastic, right? So we need to change the roughness attribute here. So roughness is typically a value of 0 to 1, right? 0 being not rough at all or glossy, and 1 being fully rough or matte. So we can create a scalar value for this. Scalar basically just meaning it's a single number, not a node with multiple channels, right? It's a single channeled node. So we'll go under constant, and it's this first one, so constant, right? So we can take this and we can plug this into roughness. And we'll see in our material swatch that it becomes glossy at that point because roughness is now being told that it's 0. And the same as we did here, we want to make this a parameter so that we can control this and customize it in material instances. So we'll convert this to a parameter and we'll call this roughness. And one thing about parameters in Unreal Materials, if you select one like this, it's got its own little details panel here, including default min and max values, right? So if you want the default of a material instance to be 0.5, like a standard material would be, you can set that as the default value here. And because we know roughness should be constrained between a value of 0 to 1, we can set those here in the slider min and max values. So we'll save this. And now our basic material here, there's a material instance, it's got a global scalar parameter value section, which includes roughness. So we can take this and change the value of that. So if I slide it down to 0, it becomes fully glossy. If I slide it up to 1, it becomes fully matte. So I'll set this to like 0.1. So we've got kind of a plasticky look here. And we'll save our material. So at this point here, I want to talk a little bit about material organization as you're designing these parameters here. Because I don't know about you, but global scalar parameter values and global vector parameter values is a little bit of a mouthful. I would much rather have this have a cleaner, more understandable name, right? So we're going to open our master material again here. which again, we're just going to double click the swatch for this material's parent, because this is a child of this master material. We'll click its parent. And then we can select these parameters that we created. And you'll see under this section here, group is currently set to none. We can just click into this so that it's highlighted and start typing a name. So we can call this basic material attributes, for example. And you'll see that it has a sort priority, which is 32 by default. So we'll come over to the roughness parameter here, and under group this time, since we've created one already, it'll now be in this dropdown. So we can say basic material attributes. And what the sort priority does is, well, let's actually take a look at what happens by default, right? So we'll go to our MI basic material, and you can see our interface updated now to have that name that we chose. So if we open this, we've got diffuse albedo and roughness one after another here now. If for some reason you wanted these to show up in a different order in this list, that's where that sort priority comes into play. So the lower this number, the higher priority it is. So if we want roughness to show up first, we can set this to 0. And we want diffuse albedo to be after it, we can set that to 1. We'll save this. And now when we look at this, roughness will be at the top of the list and diffuse will be after it. So this is a great practice to get into when you're starting to build more and more complex materials. You want your parameters to be in sections of your material that are really easy to scroll through, to read. For example, when we build our Carpaint material, we'll have a section of parameters for the base coat of paint, we'll have a section for the flakes layer, and we'll have a section for the gloss coat. So I want all of those parameters to be right next to each other, so I don't have to hunt through my material instance interface to try to find something to fine tune, right? It's much better to keep these things organized. So we'll close these. So one more concept on parent and instance, or master and instance materials. You can actually create instanced material instances. And it probably sounds confusing, but you know how we right-clicked this and said create material instance? Well, we can do the same thing on a material instance. We can create an instance of an instance. So if we do this, this is now going to have a parent material of MI basic, right? So whatever attributes that we did in this material, whatever customizations that we did, will be the new defaults for this one. So for example, if we want this to be a black plastic, right? And we'll set the roughness to like 0.35. So we've got a smooth black plastic here. We'll save this. If we want to have different variations of black plastic here, we could change the name of this to be MI basic plastic matte. And we can come into this and override the roughness here and change it to a higher value, like 0.5. Right, so we've got that. And now we can duplicate this, not instance it, we can duplicate it here, duplicate. So we'll say MI basic plastic glossy. So we'll take this roughness value and we'll set it maybe to 0.1, right? So we have kind of like a piano black look here. So why this is useful is, both of these are being inherited from this material instance. If you want to tweak the color of all of these with one adjustment, you can now. So we'll go back to that first material instance and we'll keep an eye on our swatches here as we adjust this. But say we want this to now be a gray plastic. Right, so now we can adjust this, hit OK, and save. And both of these updated as well, right? Took it a second for those swatches to update, But anytime you adjust this one, say we want a red plastic, okay, save. Both of these are also going to update. So one place where that's really going to be useful to you in automotive rendering, especially with automotive interiors, is when your color scheme of your car has 20, 30 different variations of plastics in the car, and you potentially have 3 or 4 different color schemes in that car. You might have 20 or 30 different black plastics, beige plastics, gray plastics, brown. And if you have a color code that's associated with that plastic color, then the only thing that really changes about them is what texture they are for the surface quality. What is it, a leather grain plastic? Is it a fine grain plastic? You can do color tweaks on all of your black plastics with one adjustment. So this whole instanced material instance thing is incredibly powerful for that. So you're talking again about a production environment. That is a huge time saver, because if you get a comment from your client that says, hey, every beige plastic in your renders is too green, it's too yellow, can you dial in the color a little bit closer? You don't want to have to go in and adjust 50 materials in your project. You want to be able to do it one time and be done in 3 minutes, right? So that's what this enables you to do. It's so flexible, it's so powerful. This is something that I wish Maya had for a long, long time, is the ability to be able to do this. So that is parent and instance materials, the relationship, making instance materials, right? So we're going to dive a little bit more now into the material graph. So I'm going to apply this master material onto this again. I'm going to save everything in my level, and I'm just going to go ahead and delete all of these here. So this is kind of a good time to talk about deleting assets in Unreal. You can see here that pending deleted assets, there's 3 assets that I'm trying to delete. It shows what class they are. But you'll see in yellow down here, it says there are references in the undo history, so the undo history will be cleared. Or she you want to delete these assets. So right now I'm going to hit cancel. And I'm actually going to throw one of these back on. And then we're going to save. And we're going to try to delete these now. So we'll get a different kind of result on this menu. So pending deleted assets, here's the 3 I'm trying to delete. So now we'll get a red warning message here that says some of the assets being deleted are still referenced in memory this time. It's also being referenced in the undo history. Assets referencing the pending deleted assets. So this level is referencing that material that we're trying to delete. And you can see this one right here, MI basic, is the one with a reference, right? So what you can do here is, if you don't care, you can hit force delete and it'll remove that material assignment from this object and it'll just kind of be empty at that point. Or, so if we want, we can choose a different material to put here. The only catch is it needs to be the same type of material here. So for example, in this example, a material instance. The only other material that I have here to work with is a material, not a material instance. So I can't actually choose this to replace it with. So in this case, I'm actually just going to fix what I did wrong. We set this up on purpose, but I'm going to override this back to M basic. I'll save, and now I can safely delete these. There's no warnings about it being referenced in memory this time. So let's expand on this material a little bit here. And we want the ability now to make a chrome material out of this. So we've got color, we've got roughness. What's going to allow us to do chrome here is going to be this F0 attribute. So we're going to need another constant 3 vector here. And we're going to plug this into F0. So we'll see our swatch update. Didn't really seem like it changed at all. We're going to right click this and say convert to parameter and say F0. And then we're going to choose a group on this, say basic material attributes. I'm going to set this to 1 because diffuse albedo is 0, F0 is 1, and I'll change roughness to 2. All right. Just want to make sure that those show up in the right order. or the order that I want them to show up in. And we'll close this. So now we're going to make a new material instance, and we're going to say mi basic chrome. We'll apply this to our object, and then we'll open this up and tweak this until we get chrome. So chrome, we want to set our F0 color to white. And then we want to set our roughness to 0. So just like that, we get chrome as our material here. And with F0 set to white, you can see that the diffuse color doesn't really have an effect on our material. Doesn't matter if it's black or white whatsoever. So a fully white F0 is going to override basically the diffuse color of that material. Okay, so we can save that. So again, thinking about, variations of chrome here. What if we want different types of chrome? Smoked chrome, gold chrome. We can make those by making instances of this material instance. So we'll create a material instance of chrome, and we're going to call this one chrome underscore smoked. We'll apply that to our object. We'll open that up. And then all we need to do here now is tweak the F0 color to make this a little bit darker. Right? So maybe we'll go down to like a 0.5. So now we've got kind of a smoky chrome look here. You'll see with F0 set to 0.5, if we adjust our diffuse color, you can start seeing that have an effect now, because it's kind of like it's being seen through the metalness of this material. You can kind of think of F0 as a metalness attribute in some ways. So making it pure white means that it's purely metallic, essentially. Okay. Let's make another material instance of this and say basic chrome gold. So we'll apply this to our object. Open that up. And this time we'll tweak the F0 color to have a hue here. So we'll give it kind of a gold color. Hit OK. And maybe we want our gold to be, not quite so shiny. Maybe we'll say it's 0.1, 0.2, and save. So now we've got a kind of a brushed gold effect now that's built on top of our chrome material, which is an instance of our basic master material here. So hopefully you can kind of see how this relationship between master and instance material instances kind of works, what the value of that is there. You can start building out all of these variations that are really easy to tweak as you go higher and higher up the hierarchy. You can start building these massive material libraries in this way really quickly. If the only difference between materials is like what texture is assigned to the normal map, super easy to do that in Unreal. So the next thing we want to do is, we had the kind of plasticky looking red material here. We want to be able to use textures in that material so we can give it a grain to that plastic, right? So I'm going to come back into our master material. And the way we're going to do that is by plugging a texture into the normal input here. So if we go to our node selector here, we can start typing texture sample. And this is how we're going to bring a texture into Unreal. So you can see texture samples details here has a texture attribute. And we can choose, from our starter content, there's a lot of textures that came in from that. We can start looking for capital N. Maybe we find something if we type normal. So we can see what one of these looks like. Double click this. This is kind of plasticky looking. That should work. So T-shape normal. So if we take the output node of this and plug it into normal, Now we've got kind of a plasticky, grainy, plasticky look to this. But, as we know, this is not a parameter at this point. We don't have the ability to change what texture is assigned to this using our material instance. We want to give our user the ability to swap that texture out to something else. So just like any other node in here, you can right click and convert to parameter. And we can call this normal texture. So we'll save this. And now you can see, since the rest of these are inheriting from this master material, and we basically hard-coded a normal map into it, now our gold chrome has this kind of, beaten gold look to it, right? So maybe we don't want that. Maybe we want the ability to enable the use of a texture or disable the use of a texture for an attribute like your normal map. Right, so we'll come back to this. And for situations like this, we would need basically the ability to turn this feature on and off. And the way you do this is with a switch parameter. So it's going to show up here as static switch parameter. Right? So this is going to ask for a name. Usually when I'm using these for texture inputs, I'll say, do you want to use this? So use normal texture, ? And the way these work is they have a true false kind of traffic control here. So if yes, use normal texture, we'll plug it into our texture node. And so if it's false, we're going to create a texture sample. And we're going to look for a flat normal in here. So we'll search for flat normal. We can see there's a few to choose from in here. We'll grab this. This is a normal with no, other values in it. It's going to be flat. It's not going to affect the surface of our object. And then we're going to plug this into normal here. Okay. So we'll save this. And we'll see what happens to these two parameters here in our material instance. So we'll open up one of our material instances here. And now we can see there's another new section in our parameters for global static switch parameter values. So right now, used normal texture is not being overridden, and we can see its default value is off. So we'll enable this parameter, and we'll turn this on. So now we get another new section here, global texture parameter values. So if we open this, we can turn on the override for enabling normal texture. And we can change what map is assigned here now. Right? So we can say water normal, which gives us kind of this kind of liquidy look here. So maybe that's what we want for our gold chrome. So now we get this effect. So great. So remember what I was talking about with making a bunch of variations of things. Maybe we want a bunch of different gold chromes that all have, the only thing different between them is the normal that's assigned. So we can duplicate this and say, just for example, alternate here on the end. We can open this and we can choose a different normal map. So we'll look for normal. See whatever this is. That's pretty ugly, but we'll go with it. So now we'll take our object here, we'll assign this one to it, and we get this different look now. Throw this one back on. Basic chrome. Smoked chrome. So we can start making all kinds of different looks really quickly based off of one master material. So if we open one of these up, remember we had these two sections here for, global static switch, global texture. Again, don't really like the way that sounds. So I'm going to go into the master material and we're going to categorize these. So used normal texture, we're going to put into a group called normal. And we'll do the same for the normal texture. The group will select normal. And I want the switch to be the first thing that shows up in this section, so I'll set it to 0. And we'll set the texture to 1. We'll save this. So now if we go back to our gold here, now we have a section for basic material attributes and we have a section for normal. So if we open this, we've got our normal texture and we have the checkbox right at the top. So if we disable the checkbox, that texture goes away. If we enable it, texture slot comes back. So let's do the same for a plastic material. So I'm going to create a new material instance based off of our master material here. So we'll create a new material instance. So we'll call this MI basic plastic. So we're going to establish, the default values of plastic here. I'm going to set this to be just medium gray as a default here. So we'll set, no saturation and then 0.5 on the value. Or F0, we're going to set this to 0.15. And the roughness we're going to set to 0.25, maybe 0.35. So really basic gray plastic here. Okay, under normal, we're not going to use a normal map at this point. So we're going to make a couple of smooth plastics here. So now we have MI plastic. We're going to create a material instance of this. And we're going to call this MI basic plastic black. We'll assign this to our object, open this, and for this one, I want to just override the color to be something like 0.04. So not quite black, but it reads as a black plastic. I'll save that. So now we'll make another material instance of this. And we'll call this grain 1. We'll assign that to our object, open this up, and this time all I want to change is the normal map that's applied to this. So we'll enable our normal map texture input, we'll enable the texture slot, and we'll look for a texture to use. So maybe we'll go with this one here. We'll save that. So now at this point, I don't want to make an instance of this. I want to duplicate this because all I really want is a different texture to be applied to this. So we'll call this grain 2 at this point. We'll assign that to our object, open this up, and all we're going to do is change the material, the normal map that is assigned to this. So we'll look for normal. Maybe we'll use that water normal again, save. So now we've got this plastic look. So we can swap between these to see our different plastics. And like I said, if we get a comment that says, the black plastics aren't reading dark enough, it's not a rich enough black, I don't want to have to edit both of these. I want to edit at one time. So I'm going to go up to this level and open up this, and we're going to tweak that diffuse albedo value. So maybe 0.01. So now it reads a little bit darker. Okay, and save. And now these other two have updated as well. So again, just want to hammer that in. The hierarchy of master materials, material instances, and instance material instances becomes super powerful here in Unreal Engine. Okay, so one more thing about these. We saw how to use textures in our material, but there is one thing about these that we haven't really talked about, and that is the UVs of these. So changing the UV repeats of a texture. How are we going to do that? If we look at this material that's assigned here, I've got a texture input, but I don't have a way to change how this texture is repeating across my object. Maybe this is way too broad or way too small. I need to program in a way into our master material to be able to tweak the UV repeat values. Okay, so we'll open up our master material. And basically what we need to do is give this UV's input, some information here. So the way to do this in Unreal is called a texture coordinate. So we'll create this node that looks like text chord. And if we open this, one way to do this is to just hard code in what the tiling should be. So you can do that in this node here. And you can plug in this into the UVs. So by default, it's 1 by 1. Maybe you want to set this to like 4 by 4 by default. We'll hit save. We'll see all of our instance materials update. And now that detail is going to be repeated 4 times, right? So it's much higher level of frequency of detail. That's not super useful because we want the ability to change these from material to material. So we need a way to customize this. We can see that this U tiling and V tiling, these don't have any kind of input pins whatsoever, so that we can make those into parameters, because that's really what we're after here. So what we need to do is we'll leave this at the default, but we need to create a couple of additional nodes here that will allow us to multiply the effect of this, or the scale of this. So we want to be able to change the U value and the V value separately from each other. So those are both going to be scalar values. So we need to create 2 constant nodes here. So 1 and 2. And I want these to be parameters. So I'm going to right click these and say convert to parameter. And we're going to call this U repeat value. We'll make this one a parameter and call this V repeat value. And remember, these have default values. They're currently set to 0. So if we plug all this in, our UV repeats are going to be 0 by 0, which is just going to make it look really weird. Texture is not going to show up. So we want to default these to 1 and 1. Okay. So the next thing that we need to create a vector out of these 2 values, right? This output pin here is going to be actually outputting a vector value. So it's a U and a V value here that are getting plugged into UVs. So we can't plug in just one of these because it's going to be just a U value or just a V value. That's not going to work. What we need is a vector. So we need to add these 2 values into a vector. And there's a node for that called append vector. So this takes an A input, which will plug into our U repeat value, and a B, which will plug into our V repeat value. And what we want to do is multiply our texture coordinate UV value by whatever is in these 2. So we're going to use a multiply node. So we're going to search for multiply and create that. So we'll plug the output of this into the A and the output of this into the B. And then we'll replace that connection to the UVs. Okay. So remember, we need to categorize these. So we're going to make a group in here for UV repeat values. So we'll save this. We'll see our material get updated because those values changed. We'll open that material, and now we'll see a new category here for UV repeat values. And if we disable the normal texture here, we'll see that whole section go away, because these are actually being inherited from the pipe that goes into the true pipe of that switch that we created, right? So if we're not using a texture, there's no UVs to worry about. That whole section gets hidden, which is a really nice, organizational thing. If your material has simpler features enabled, your interface is going to be simpler for it. It's great. So I'll turn our texture back on, and then we're going to enable the U and V repeat values, and we can set these to a higher number. So we'll say 4 by 4 or 8 by 8. So we can really increase or decrease the scale of our textures that way. So there's one more thing that is useful for UVs. So we'll take these and move these over. And sometimes it's beneficial to be able to rotate the texture on a material. So there's a node that we can use for this. It's called a custom rotator. So we'll add this, and we're going to take UVs as an input here. Rotation center is going to default to 0.5, 0.5, which is the center of an object, so that's good. And then rotation angle will take an input. So we need another constant for this. And you can see it's a value of 0 to 1. 1 is equal to a 360-degree turn. 0 is 0 degrees. And the little s here indicates that it should be a scalar value, which is what we have here. So we're going to right-click this, convert to parameter, and we're going to call this UV rotation percentage, just to eliminate any confusion. Since this is based off 0 to 1, you need to input a percentage value, because you might think, oh, I want to rotate it 180 degrees. So you might put 180 here. It's basically saying 180%. We don't want that. So just make it really clear for yourself later, or for someone else who's using your materials, that this needs to be a percentage. So a 50% rotation is a 180-degree turn. A 25% rotation is a 90-degree turn. That kind of thing. So we'll plug this into rotation angle, and then our rotated values we'll plug into UVs here. Okay. So we've built out all of our functionality for adjusting our UV repeat values. We'll save this, and then we'll see what that looks like in our material instance. So you can see we forgot to categorize that. So let's go back and fix that. Back to our master material. UV rotation percentage. Let's put this into the UV repeat values category. We'll save that. And now under UV repeat values, you can see it came in a little bit out of order. So again, that's where that sort priority comes into play. Let's fix it, Let's go into U repeat value, set this to 0. V, we'll set it to 1. And rotation percentage, we'll set that to 2. Save. So now we've got these in a nice order here. So we can take our UV rotation percentage, and maybe we want to rotate it 90 degrees. So we'll say 0.25. It rotates. 0.5. It's a 180. 0.75. It's a 270. And then 1 is fully rotated, or essentially has no effect, right? So it gives you the ability to rotate your UVs. And that's great. So there's one other concept here for materials in Unreal Engine before we move on. We built this little group of nodes here that is really helpful. This kind of performs a function on our material, right? So it would be nice if we're making a bunch of different master materials and we don't want to have to recreate this. How do we save that in Unreal as a function that we can use as a single node? So these little light blue nodes here, like this custom rotator, this is actually a material function node, right? And material functions are custom node setups in Unreal that you can actually go into by double clicking. So if I double click this custom rotator, now you can see in our graph says material function, right? So this is its own little node network that does stuff and has an output. This is how we create functions for materials in Unreal. And this is a great opportunity to create one. So what we can do is take all of these nodes, right click and copy. And then in our material folder here, let's create a folder for material functions. We'll right click and say under material, there is material function right here. So for material functions, we're going to call this mf underscore, and in this example, it's going to be UV controls. Save that. When we open this, the only thing that should be in here is an output result. So now we can paste in those nodes and use that as the output. And you'll see kind of a UVW tile here, right? So we'll save that function. We'll come back into our master material here. And instead of having all of these nodes, we'll delete those. And we're going to add our material function. So we'll go into that folder. We can just drag it into our material. So now we've got this to plug into our UVs. So we'll save this. And if we open up our material instance, really nothing has changed. All those same parameters are there because they're being passed in through the function. So incredibly useful for setting up stuff that you don't want to have to program a bunch of times. You might as well set it up as a function and only do it once. So material functions in Unreal are super powerful for that. One last thing about material functions here. You notice how we drug that into our material? We can actually set something up in here so that we can search for it in our right-click menu. So if we go into our material function and we click off of anything into the grid here, within the settings, there's this checkbox for expose to library. So we turn this on and save. Now in the right-click menu, we can search for our function. So instead of having to go through the folders and drag it in, you can just search right for it here. So an even faster way to get our material functions into our materials. All right, so moving on here, the next thing we're going to build is a glass material. So I'll go over to my materials folder here, and this time we need to create a new master material. This is going to be a different Unreal material archetype than the one that we had built previously here. So we'll make a new material, and we're going to call this m_glass. I'll open this up, and we need to set a few different settings here than we did last time. So first thing I'm going to do is delete the default node, and I'm going to make a substrate slab and plug it into our front material. So when you click on the graph here, or you click on your output node, on the left of the details here, you can see there's a blend mode. There's all these different settings in here for, what type of material we're looking at. So we're going to change blend mode to translucent colored transmittance. This is essentially the highest quality glass material archetype that Unreal can do. And we're going to set a couple more properties here. So under lighting mode, we're going to set this to surface forward shading. And if you scroll down a little further, there's going to be under refraction method. And we're going to set this to index of refraction. Okay, so that's all of our details set up to prepare us to make a glass material. So the first thing that we're going to do here is we're going to make a parameter here for our diffuse albedo. So if we remember, our diffuse color is going to be a constant 3. We're going to make this a parameter and say diffuse albedo and plug that in. Next, we're going to make another one here for F0 and F90. And just as a quick tip here, when you're creating these nodes, there are keyboard shortcuts for nodes in the material graph. So for example, if I hold down my 1 key and left click, that's going to make a constant 1 or a scalar value. Number 2 is going to make a 2 value, 3, 4, so on here. There's a bunch of other shortcuts here, so you can kind of just experiment with what's on your keyboard, like holding down M is making a multiply, L is a lerp. There's a lot of really quick shortcuts in here for constructing materials in. So I'll hold down 3 to make a constant 3, and I'll make another one here. I've got 3 constant 3 vectors. I'll convert this one and say F0, convert this one and say F90, and we'll get these plugged in. So next we need a roughness attribute. So for this one, we need a scalar parameter for this. So remember, a value between 0 and 1. The shortcut for a scalar parameter is just to hold the S key. So if you hold S and left click, usually fills up with S's in the name here, but we can call this roughness and set that into roughness. And remember our min and max values here, roughness can't go over 1, so I'll clamp that between 0 and 1. Okay. So over on our output material here, you'll see when we set this to refraction, index of refraction, we can take an IOR input now. So another scalar input, we'll call this one IOR. We'll plug this in here, and we're going to set this to a value of 1.5 by default, which is kind of in the neighborhood of glass, if you're familiar with material IORs. So next here, we're going to make a substrate helper node. So we're going to come down here to substrate helpers, and we want to create a substrate transmittance to mean free path node. And we're going to plug that MFP into SSS MFP. So substrate is really scientific with how it works. Mean free path is basically like the thickness of your material and how deeply light can penetrate and bounce around. This helper node is kind of an abbreviated way of using that. So it has an input of transmittance color. So we'll make another constant 3 vector, right click, make this a parameter, glass color, and plug that into transmittance color. Okay. So we're going to take this and we're going to set the default value to white. And we should start seeing something that looks a little bit like the beginnings of glass here at this point. All right. So for our F0 and F90 values, we're actually going to set these to the Unreal defaults. If you hover over, so we'll set this to 0.04, excuse me. And F90 should be 1. So it's really starting to look like glass now. Great. So we're going to save this, and we're going to make a material instance of this and call it MI glass. And we'll apply this to our object and see what happens. Okay. So we start getting something that looks pretty much like glass here. It is refracting light as something passes through it. You're able to see through it here. It's translucent, it has reflections. It may not look perfect, but this is actually a pretty big step up from the real-time glass in previous versions of Unreal before we had Substrate. So we're going to open our material instance here, and we'll play with some of these values just to see what happens. So I'm just going to enable all of these. For the glass color, let's just try making it a color here. So red glass. We can see what we've got here. It's a pretty decent red glass. Under roughness, if we increase the roughness value, we'll start getting a frosted glass effect here. So this is something that previously, before Substrate, was not possible in Unreal Engine. We could not diffuse the reflection of a transparent surface. So this is a huge improvement here for glass rendering in Unreal Engine. So we can play with a couple more of these values here and see what happens. So if we change the IOR, we can kind of see what that fake refraction effect is doing. It's just kind of warping the scale of what's behind our glass there. If we set this to 1, I found that this ends up looking pretty clean, but it doesn't really look particularly like glass necessarily. There are still some limitations in Unreal for glass rendering here, but just keep in mind this is a big improvement from where we were before this. So we'll set this back to clear, and we'll bring our roughness back down to 0. And we'll set our IOR back to 1.4, we'll say. So again, not perfect, but it looks pretty decent. One of the things that I have found you can do if you do have the colored glass here is with the value here. The default of 0.4 is kind of just like a PBR value that's realistic for glass. If you do increase this, like if you crank it all the way to 1, you get chrome. Remember how we do that with Substrate, but if you crank it up just a little bit, you can kind of enhance the reflections on your glass just to make them pop. This is something we always fought with glass materials in, the previous material system in Unreal, is we would get glass pretty often that looked like this, where it just didn't seem to reflect anything. So setting this value up just a little bit higher, you can kind of fake that effect a little bit. And you can also tint the F0. So if you want, for example, on a red glass to have a little bit of a tinted reflection on there, you can just kind of art direct your materials in this way and make it a little bit more suitable for your render that way. But if you want to stick to being scientific here, you do pure white and 0.4 on that value. Okay. Okay, so right now I want to take an opportunity to show just one additional feature about rendering in Unreal Engine. We're going to cover this just very briefly, and then we'll go into a much deeper dive on it in the lighting and rendering videos on this. This is a great opportunity to highlight how the path tracing renderer in Unreal Engine differs from the standard rendering engine, which is Lumen here. So under our lit menu, we've got under our view modes, there's one in here for path tracing. And if you don't see that in your list here, you may need to go into your project settings and search for path trace, hardware ray tracing, enable path tracing. Just make sure this is turned on, and you should have this in your menu here. But if you enable path tracing, this is going to switch Unreal over to the path tracing renderer. And you'll notice right away here, glass looks much closer to what you would expect to see in something like a Arnold or V-Ray. It realistically bends light. It has an inverse refraction, when you're looking at a spherical object. We can see that much more clearly here if we create just a regular sphere and apply our material to it. So if we look at this and kind of scale this up, you can see our sky is on the bottom of the sphere, the ground is on the top. It's an inverse refraction at that point. Now this is much more realistic as far as glass rendering is concerned. So if we toggle back and forth between Lumen and path tracing here, there's a pretty dramatic difference. And, this is what we would like to see in something like Lumen. Unfortunately, we're not there yet in Unreal. It's got quite a ways to go to get to this point. I'm really hoping that with Substrate, when that becomes beta or production ready status, refraction is a little bit more advanced than what it is now. But just wanted to give you just a quick little preview of what path tracing can do in Unreal Engine. So you can see down at the bottom here, we've got a progress bar that's happening here. So our one frame here that we're rendering, it's no longer real time with path tracing. It's still quite fast compared to something like Arnold or V-Ray, but it is no longer real time. You're fully into offline rendering at this point, and that has some drawbacks and benefits. So just a really quick preview of what path tracing can do. Otherwise, in Lumen, we're going to have to work around the limitations of Unreal's refraction capabilities right now. So that's just a brief overview of glass materials here. So we can now go in and create some variations of glass. So I'm going to take our material sphere here, and I'm going to hold down Alt and drag on our gizmo to duplicate this a couple of times. And we're going to see side by side some different variations of glass here. So if I duplicate our glass instance, we're going to call this one MI glass red. We'll apply that to our middle one here. And like we showed a minute ago, we'll take our glass color and make it red. Okay. So we'll duplicate this again, and we're going to call this one frosted. Apply this to our last one. And we'll make the glass color white and bring our roughness up to 0.5. Save that. So we can start seeing, some variations on glass this way pretty quickly. We can make a bunch of different versions of glass very easily. But what if we want to make our glass material a little bit more advanced here? So I'm going to go into our glass master material here. And we're going to say maybe we want the surface of our glass to not be perfectly smooth. So we can do the same thing that we did in our other material, and we can add a bunch of controls for a normal map. So the cool thing about this is you don't have to do all of that by hand again. We can come into this and just grab these same controls, right? These same parameters. Come into our master for glass, paste those in, and just get those connected. So even our material function comes in. We've got our normal map functions here. And you can see, with ideas like this, we can start building out a whole library of master materials and all of their variations pretty quickly. Once you start building out node networks like this, you typically don't need to do it again. Even the names on these, if you're building these in a organized, efficient way, you shouldn't even have to rename these things. Like, this is still a normal input, normal texture. So we'll save this and close that. And so maybe our red glass here, if we open this up, maybe we want to use a normal texture on this one. So we'll enable our normal texture, enable the material slot, let that shader finish thinking and compiling. And now when we look at this, the surface of our glass is now a little bumpy, right? So it's super easy to make textured glass. This can often hide some of the weird effects of refraction with glass in Unreal. So you can kind of get creative. You can also make texture inputs for the roughness if you wanted to have, kind of a dirty looking glass that has streaks and fingerprints and stuff. You can throw a texture onto the roughness and have areas of it kind of be a little bit more frosted than other areas. So all kinds of great stuff that you can do with glass here in Unreal. All right, so the last material that we're going to make for this video is going to be a Carpaint material. So there's a few videos on this on YouTube already about creating a Carpaint in Substrate, but I do it a little bit differently, and I'm going to expand on a few elements of the material that I haven't seen anyone else cover yet. These are a few things that I've found that are useful for rendering Carpaint in production. So we'll create another new material. We're going to need to make a new master for this. And we're going to call this M Carpaint. So in our Carpaint material, we're going to delete the default node. And we're going to create a new slab. So we'll plug this in so we can start seeing what we're building here. And we got to start thinking about what actually makes up a Carpaint, right? And also, what type of Carpaint are we going to be creating? So Carpaints out in the world, they have different properties, like if it's a metallic paint or if it's a more of a ceramic paint with no flakes in it. Is it glossy? Is it matte finish? Is it like a vinyl wrap? There's a few different things that can make a Carpaint, and it would be great to give our artists or ourselves to the ability to choose what type of Carpaint they want to construct here. So we're going to start with the metallic Carpaint. This is one that we kind of see on YouTube already a couple of times. It'll show you what's different about how I create these. So we're going to start with the diffuse albedo here. So Carpaint has a property called the flip-flop color. And essentially what that means, if you look straight on, like a 90-degree angle at a part of Carpaint, it'll be one color. And then as you turn that plane and look at it from a glancing angle, it may be a slightly different color. So that's the flip color and the flop color. And you'll hear me talk about those quite a bit as we create these. So I need to be able to make two different colors make up this car paint. So we're going to make two constant 3 vector nodes here, holding down 3 key and left clicking. And we're going to make both of these parameters. So we're going to call this base coat flip color and base coat flop color. And so for example, we can make one of them orange, and we're just going to keep this simple so we can see really clearly, one of them green, so complementary colors here. So we need to be able to combine these and pass the combination of them into the diffuse albedo here. And the way we do that in Unreal is with a node called linear interpolation, or LIRP for short. So you can find that here by searching for LIRP. You see linear interpolate, or we can hold the L key and left click. So we're going to plug the flip color into A, the flop color into B, and we need to provide an alpha for this to work. And what we use to do this is going to be a Fresnel node. So we can search for Fresnel, create this, and we're going to plug that into the alpha channel. So we'll plug this into diffuse color, or diffuse albedo, to see what we get here. And we can see the effect that we're looking for. It is orange looking straight on, and as you look around the edges, we kind of see that green coming through. And we can control how far that green spreads with the exponent in attribute here of the Fresnel node. So we'll need a scalar parameter to control this. So we'll hold S, left click, and we're going to call this base coat flip flop length, and plug that into exponent in. So we'll set the default here to 1, so we get a good spread of our orange and green colors here. So the next thing we want to do is kind of repeat this, but for the F0 input of our material here. So I need 2 more constant 3. We'll need a LIRP. I need a Fresnel and a scalar parameter. So we're going to call this scalar parameter here flake, flip, flop, distance. We'll set it to 1 by default, and then we'll plug all these in. Convert these to parameters, so we'll call this flake, flip color, and flake, flop color. And we're going to plug this into the F0. So we'll set our defaults for these. Colors on these is going to be a little bit wild, but you'll kind of see why we do this. Set this to red and blue here. So the next thing we need is we need to be able to control the roughness of this layer of paint. So we'll make a scalar parameter, and we'll call this flakes roughness. And plug that into roughness. We're going to set that default value to 0.5. And so how we actually get our flakes to show up is going to be this input here called glint density. So we'll make a scalar parameter for this, and we'll call this flakes density. Plug this into glint density, and we're going to set that default value to 15. And then we need to give the flakes a UV to work off of. So we're going to create a texture coordinate. We need to multiply the scale of this so that we can control the scale of our flakes. And we'll make one more scalar parameter called flakes scale. We'll set this to 10 by default. And then we'll plug this into our glint UVs. So now we should start seeing an effect here that is, a metallic car paint. So maybe we're looking a little bit too glossy here by default, so maybe we bump this up to 0.8. That is a little bit closer to a base coat of paint. Remember, we're constructing what's underneath the clear coat of a Carpaint right now, so we're going to build the clear coat next here. For the clear coat, we're going to do something we haven't done yet, is we're going to create another slab in the same material. So to create this other slab, we're going to create constant 3 for a diffuse albedo, and we're going to leave this as black. And we're actually not going to make this a parameter because we don't want to override this. So next we need a scalar value for F0, which we're going to set to 0.05. We're going to create a scalar parameter for clear coat roughness and plug this into roughness. And we're going to default this to 0.01. And so the next thing we want to do is combine these two layers of paint, right? So the way we do that in Unreal is going to be with a substrate vertical blend. So we can search for vertical, and we see substrate vertical layer here. So this takes a top input, a bottom input, and a top thickness input here. So we'll plug our bottom into our base coat and our top into our clear coat. And then we're going to plug this into the front material of our result node and see what we get. And see, kind of just turns black. And the reason this happens is the clear coat currently, we don't have anything in here telling it that it should be transparent at all. You know, we have it saying it's black. It has 0.05 for the F0 and it's very, very glossy, but nothing saying, hey, you should be able to see through this with a vertical layer. And the way we do that is with this attribute here, top thickness. So we can create a scalar parameter and say clear coat thickness and plug this in. And we're going to default this to a really low value like 0.003. We still don't get anything really showing through because remember, with transparent materials in Substrate, SSS MFP needs to have an input here. So this is where that transmittance mean free path node comes in again. We'll plug this into SSS MFP. And all of a sudden we've got a clear coat on top of the base coat of our paint here. So that's looking great. Let's go through and categorize everything and organize everything. So we've got our base coat here. And what I want to do is start commenting out this material. So if I select all of these nodes here for our base coat, I can hit the C key and we get a little backdrop here. And we can call this base coat. So we'll do the same for the clear coat here. Select those and hit C, and we'll say clear coat. And then with our vertical layer here, we can call this combine base coat and clear coat, just so it's really clear. Okay. And then for all of our parameters here, first thing I want to do is categorize all of these into our base coat, flake layer, and clear coat. So I'll take anything that is related to our base color here, and we're going to call this base coat for the parameter group. I'll take all of these that are flake related, and we'll call this flake layer. And then our parameters for the clear coat, which is really these two, we're going to set this to clear coat. And then we'll compile our material, save it. And we can see what we get with this. So first I'm going to make a material instance of this, call this mi Carpaint, and we're going to assign this to our material sphere. So we open up our material instance, we can see all of the attributes that we've created here, right? So we've got base coat, clear coat, flakes. If we zoom in on our material here, kind of see the effects of our material. So because of that Fresnel function that we plugged in a couple of places, pretty much any angle that we look at, what is facing us here is going to be our flip color. As it goes around the edges of the sphere here, it's going to start showing that flop color. So that's great for designing, those really dynamic car paints that, you look at one angle, it's one color, look at another angle, or the car turns, it kind of shows a different color there. So let's replicate one of my favorite car paint colors. This is called Deep Forest Green by Ford here. So if we look at this, it's a metallic green that's very, very dark. The flop of this goes almost black here, as it is, on the corners here and kind of facing the camera, this a little bit brighter of a forest green shows through. So let's see if we can recreate this here in Unreal. So I'm going to start with the base coat, and I'm going to go ahead and set these to black for now. Make this really dark. So the only color that we see in our material now should be coming from our flakes, right? So we'll take our flakes and let's focus on that flip color first. So I'll set the flop to black. And when I'm creating car paints and trying to replicate things that I see through photos or in person, I try to isolate different areas of the paint as I'm creating this. So we know that that green, is kind of a bluish, deep green. We don't want to go too blue, but somewhere in that neighborhood. And it is pretty dark. So we'll bring this way down. And honestly, already this is pretty close to what we have here. It's in the right neighborhood. We can definitely dial this in a little bit closer, but within a few seconds, we've got a passable representation of this color. So let's say the flakes, let's make those a little bit brighter. And let's dial in the base coat to actually put a little bit of that same green in there. So what you can do if you want to borrow colors in Unreal, there's a couple ways to do it. The easiest, the fastest one is to use the color picker here. We can sample something within our scene here. So maybe I find one of these bright flakes in here and sample that. So maybe something there. So it's in the right neighborhood of green. It's not black. And we can pull this up just a tiny bit and say, okay. So we can sample the flop color here and pull something that's pretty much the same thing, but just the hair darker, because we want that to fall off, as we see in our photo here, right? So there is essentially deep forest green. We could put a color into the flop color, but honestly, for something like this, it's going to be almost black. And it's not going to have that much of an effect. So we'll save that. Zoom in on our paint here just to kind of see what we get. And it's looking pretty good. I like that. I'm actually going to switch over to the path tracer and see how this differs between Lumen and the path tracer here. So you can see there's quite a huge difference there. This is something that is a challenge with Substrate and Unreal as it stands right now. Is some of these features in these materials, they'll render quite a bit differently between the two renderers here. So like we saw, I dialed this in for Lumen, and maybe that's fine if my project is never going to use path tracing, but a lot of times in production when we're doing high-end stuff for automotive clients, you want the best result possible, which means you're probably going to be path tracing. And if that's the case, you should be tweaking your materials in this view. If that were the case, we need to edit this so that it works for path tracing, right? So I'll pull these values down, get it to the point where it looks nice with path tracing. And it may even seem like the scale of these flakes changes a bit between Lumen and path tracing, so maybe we want to come in and change flake density and flake scale. If I pull this flake scale down, you kind of see what happens. So add a value of 3, 2, 1. Depending on how far away your camera is, you might need to fake these attributes sometimes. If you're doing a close-up shot, like a macro shot of something on your car, you definitely want these to be pretty fine, maybe something like 15 or 18. But if your car is pretty far away and your client is saying, this is supposed to be a metallic car paint, where's the car paint flake? And you're like, man, it is 1,000 feet away in this shot. You're not going to be able to see the car paint flakes. Sometimes you got to fake it. And so you can do effects like this where you're far away, but you can still tell that there's flake in that car paint, right? So it's all a game of balance, give and take, what makes sense for your shot. I wouldn't expect there to be a one-size-fits-all material for every situation, but just know that if you build car paint material like this, you essentially give yourself the freedom to make something that fits for all those situations. So that's a metallic car paint in here, right? The cool thing about this is with this flake density and flake scale, if we take this down to 0 here on the density, we've essentially got a non-metallic car paint at this point, just like that. All right, so with non-metallic car paints, the flip-flop on the color is usually less dramatic. So I would maybe take our flop color and bring this up a little bit closer to our flip color. So something like this. So we were here, goes pretty dark around the edges. Just pull this up so they're almost the same color. Our flake layer really doesn't matter at this point, honestly, so we can just close this. So now we've got a non-metallic version of deep forest green here. And one further thing here with our clear coat, with the clear coat roughness, if we bump this up to a value of 0.4, 0.5, 3 maybe, you get that look of a vinyl wrap really easily. So maybe 0.25. Vinyl is shiny. It's not very shiny, but it has this kind of diffused glossy look on it, something in this neighborhood. So there's a vinyl wrap version of deep forest green here. I'll set this back to 0.01, and I'm going to turn the flakes back on because I like the way those look. Okay. So there's a car paint in Substrate. Pretty simple material, really. There's not too much that goes into this, but it is the first time that we see blending two substrate slabs together to make one material. And there's other ways to blend substrate slabs together. This is a vertical layer. You can also make horizontal layers. So what that's used for is, I'll pull up the Unreal Substrate documentation here. Basically, a horizontal layer is for combining materials that are at the same level of surface, right? So something like a, rust stain over metal or fingerprints on glass, that kind of thing. Substrate you can think of as a chunk of physical material that has thickness, right? So things that are next to each other, the surface of them, you can see the surface of each one. The vertical layer, like we just did, it's two chunks of material that are one on top of the other. So this was our car paint, the base coat. This was our clear coat. Clear coat was on top of it. If we wanted to make a rusty metal, we would use a horizontal blend, and we'd be able to see both of those materials clearly depending on how we're masking the visibility of each one in that horizontal layer. So we won't build one in this video, but we might make one later when we're prepping materials for our car. But just know you can come to this page for documentation on Substrate and see what all of the different Substrate nodes do. It's really a good resource for learning more about this new material system. All right, so we covered tons and tons of content in this video. It's nearly 2 hours here at this point. Hopefully you learned a ton about working with materials in Unreal Engine here. I'm sure you have lots of questions. If you do, please don't hesitate to ask. Be happy to respond in the comments here. There's lots of types of materials that we did not cover. and we can go over more of those as we go through our next few videos. But as a basic overview to using Substrate, building materials in Unreal Engine, seeing what parameters are, material instances, master materials, as well as, how these things really differ from building materials in Maya with Arnold or V-Ray or Redshift. I hope this is a good primer for you, and, please just let me know what questions you have. Otherwise, we'll be looking forward to diving into more details about lighting in our next video here. So thank you so much, and I'll see you there. If you learned anything from this free video on YouTube here, please leave me a like and consider subscribing to the channel, and look forward for the next videos.